Hello folks, welcome to another demo video. What you see in front of you is an RC circuit, or specifically a low-pass RC circuit. I will show you how these filters show up in a graph in oscilloscope, and I also want to show you the high-pass RC circuit as well. So as per the drawing, I have a 1500 ohm resistor and a 220 nanofarad capacitor with a 6 volts peak to peak of amplitude. The frequency right now is 300, and I'm going to set that up right here so you guys can see. As I'm altering the frequency, we'll see what happens to this graph. And we are also going to show you the amp. We'll also turn on this as well as our capacitor voltage. And I'll set this up. So now you're seeing a voltage for your source and voltage for your capacitor. And my goal is today with this circuit is I want to see the maximum output voltage after the resistor, which means I want to see the maximum voltage for capacitor, which is represented as blue. So starting with 300 hertz here, I'll zoom in for you guys to see. And I want you to pay attention to the sine graph of the blue, because yellow is not going to, because the source voltage is not going to change, but my blue is going to change. Right now I'm reading 6 volts for source, and amplitude for the blue is close to 5 volts. I'm going to be slowly dialing this frequency up, and if it's low pass filter, as you guys know, it should filter out everything but low frequency, right? It should filter out the high frequencies, which means I should be getting a very, very low voltage on my blue side. So I'll demonstrate that. Okay, I'm going to stop right there. We've increased the frequency from 300 hertz to 23 kilohertz. And right now our output is reading, it's fluctuating, but average of 100 millivolts, which is 0.1 volts. If I'm providing 6 volts and only 0.1 volts is going through the capacitor, we can say that is a very minimum output. So if I was to plot that into a graph, the voltage versus the frequency graph, it would look like this. Next, I want to demo a high filter of RC circuit. I've simply just relocated or swapped the places between the resistor and the capacitor. Their values stay the same. The voltage from the function generator 6 volts stays the same. And as you can see, I've set the frequency to 100 hertz, and I'll see what happens. In theory, it should filter out all the low frequency, allowing only the high frequencies. And once you've seen the values, as I'm changing the frequency, you're going to be focusing on the output, which is the blue, right? The yellow is the source voltage, so you won't see that change. Note that my amplitude value is a bit higher than what it's actually inputted, 6 volts, 6.2, so about 200 millivolts off. We'll keep that in mind. So if this was adjusted, we'll see that the amplitude at the output going to the resistor is only about, if this was taken into consideration, only 0.9 volts or 900 millivolts, which is nothing out of 6, right? This is when it was at 100 hertz. So I'm going to increase the frequency now and see what happens. Okay, immediately as I'm dialing up, it's becoming the maximum. It's getting close to the maximum voltage. Not sure. Okay, I have to really. Okay, you can see that the source voltage has stabilized, is coming close to 6 volts now, and my amplitude of output voltage amplitude is getting super close to the source voltage. Right, and they're perfectly in phase as well. What does that mean? You guys remember from the phasor diagram, the source voltage always got pulled down because of the capacitor reactance. But in this case, because the frequency is really high, therefore your reactance for capacitor is almost nothing. So there is no pull down force from the capacitor side, which means it will just be left with the resistor voltage. It will be, the circuit itself is considered as a resistive circuit, which now you can see that you're dissipating all that voltage across the resistor. Okay, we're only losing about, I don't know, about 600, 700 millivolts across the capacitor, and it's perfectly in phase. I'll show that in a minute. I'll show both phasor diagram and the graph in relation to frequency and the output.